So work on our stall alley is progressing beautifully. We're taking lumber from stacks and creating walls and part of the structures. So I recently got asked why we're building a row of stalls when we've never really stalled our horses before. Well, that's a really good question. We do in fact believe in keeping our animals as natural as possible. However, at our last farm, and especially when we started the Mustang training program, we quickly realized that having these wild horses in a group made it very difficult to separate them out for training. In addition, it kept them bonded very closely together so that they slowed their bonding with the humans. So we decided for this farm, we were going to set up the facility with stalls that are used strictly for training purposes. It allows us to separate out horses, keep them safe, keep them from getting into kind of a mob panic mentality if anything happens, and it allows them to start bonding with us as humans during their training session. But they're not here for long. We have every intention of building a paddock paradise in the near future so that any domesticated or gentled horses can actually be back in that herd environment. Be sure to check out our paddock paradise video if you're not familiar with that concept. But that's why we're setting this up. Horses in training sometimes have different needs for setup than your pet resident horses. That's why we're doing this.
It's a money mess.
We had severe storms last night, overnight, and yeah, this is just a wet, soppy mess. A cold front moved in, and it's quite chilly out here. So not exactly a builder's dream day, but we've got 2 days of dry weather, semi-dry, and then more rain moves in. So we're gonna see what we can get done.
So when the excavator made this pad, he tried to make a crown in the middle. So the center here, where the alleyway is going to be higher in elevation than the very end of the barn. So what we're doing here is we're picking a datum point. In other words, where am I going to measure all my heights off of? All right, so we came here, and that's going to be ground level right there. And then as we come down to the other end, you can see that ground level is kind of high down here because, again, there is a crown for water to flow. And that's fine because, you know, I can add additional fill in the middle here to make sure that it's not too deep in that stall. But the good thing is that water on the outside of these stalls will continue to flow out and away from the barn, and that's a good thing. So the key is that if this is level with that, then my roof will be level all the way across the 100 feet. And this here is a handy little gadget. It's a line level, and you can select grades in there. It's probably real hard to see there, but you've got 1/8, 1/4, 3/8, and 1/2. But 0, a level line, is right there at 0. So we're trying to make this level from left to right. Hopefully we can do it. Forgive us, it's a little windy today, but what we did was we skirted the entire structure to establish our datum, in other words, ground level. From there, we measure up from the bottom all the way to the top of the beam, but as you can see, the ground is not level, but the boards are, so there's a much bigger gap down there than there is down here. But I measured from the bottom all the way up to the top where I need to cut for my roof. Now, I kind of use a technique that I learned years ago from a friend of mine. Draw your measurements here on the boards so that you've got everything down pat, and if you have to reference it again, you can, because when you wad up a piece of paper in your pocket, you'll just never find it again. But if you draw it here on the boards, draw your measurements and markings, you can always reference it right there. So we're going to get started on getting up the headers for the roof. Well, here we go. We're going to start cutting, and if I cut it wrong, there's no going back. of the things we do here to hold up our headers and our rafters, essentially, is we notch out the posts. It's a lot of work. Some people do this before they put the posts up, and they go to great lengths to level the bottom. We didn't really have that option because of several things here, so we had to cut them up here, which is not ideal. But when we notch this out, the weight of the roof actually sits on wood. This post can hold about 20,000 pounds vertically, and all the weight goes right on the wood. Some people actually attach things just with screws or nails. Screws and nails can't hold a lot of sheer weight. In fact, if you have tornadoes and high snow loads, the roof might be rated at 20 pounds per foot, but if you don't attach these correctly, those nails and those screws will just shear right off and bend, and you'll collapse, even though the rest of the structure can hold it fine. So I always make sure that anything that's bearing a load is actually sitting wood on wood. I don't allow fasteners to carry a load. I talked about headers going wood on wood. Well, there's another way to do that. You can actually have a header up at the top that's not notched on a beam, and in this case we couldn't particularly do this one, but then you draw wood down the side of the beam that is fastened to the side of the beam that basically distributes the weight from that header all the way down. Now that one's not nearly as important because it doesn't hold the weight of the roof, but it is going to hold the door, and it's going to hold the siding and different things like that. So again, I can run the load all the way down the beam using these 2x6s going from the foot all the way to the top. So as you can see, we're going to have this go all the way up to the header, and this might be overkill for a lot of people, but I come from a family of carpenters that overbuilt everything. So I talked earlier about wood on wood, and this is where I was notching out the posts, and now I've got the headers going directly with the full weight of that going directly into this post. And I also talked about there are some times where you can't go wood on wood. Well, these joist hangers are specifically designed and engineered to hold a certain weight. But you'll notice that the joist hangers sit in there, and there are 8 screws per hanger. And they're specifically designed to take that load over the fasteners. So it takes a lot of work to actually hold weight, but this doesn't hold nearly as much weight as this board here, and that's why this one is wood on wood. Now this is a very unique design. We found this design as we were doing some research, and we actually redesigned our roof to try this out. We've never tried this before. Some of you may notice the rafters are in a little bit different orientation, and there are no purlins. This is a purlinless design, I guess you would call it. The other thing it does is it modularizes each section. So this 12-foot section, that 12-foot section, they're all actually separate roofs. Now, in an engineering perspective, if you overload one part of the roof and a portion comes down, all that load is transferred to the rest of the roof, and you have a domino effect, and you can collapse the whole thing. Not with this, though. All this load on this section is concentrated on this portion of the roof. The other thing is, because we were a little short of wood and a little short of time, I would have to spend another 2 days getting enough purlins to do this. So normally the rafters would go this way. We've set them this way, and there are no purlins because the metal goes directly into the rafter. Now there are some things about this design I like and some things I don't like. I think on the barn, I'm going back to the traditional rafters with purlins. So a little bit about a siding. This is going to be the siding on the stalls and the barn and eventually the house. It's board and batten, and in the old days the board and batten was very useful because they build a lot with green lumber, and when you build with lumber like this, it's going to shrink and there's going to be gaps that form in the middle. And so what we do is we put the boards up this way, we plane this side so it's easier to stain or put a sealant on later. The other side is just rough. We don't care about the other side so much as this outside. We want to protect it. When you plane it, it takes that protectant a lot better. But once these boards shrink up, you'll see big gaps forming in here. Now on some sheds, you want to just leave those gaps there and allow airflow through. And I did that on a shed back at Redgate Farm 1. But here, we're actually going to close it up to the weather and on the barn. We'll do that by then putting the battens right there over those gaps. We'll do that later on. We'll also stain those both sides and protect those. So you will have the battens here and the boards there. Up on the top, we tried to cover all the screw heads with that ladder structure that supports the roof. And then on the bottom, we may add trim later also, but we haven't determined that yet.
There's a lot of ways to design a horse stall. And as we mentioned earlier, we're over designing ours, overbuilding it for just, to be really tough because we deal with drafts and wild horses, and we want to make this as all purpose as we can. So one of the things we've decided to incorporate is what we call a kick plate, basically. So the area of the wall, basically the 4 feet from ground level up, that's the area that's most likely to be kicked at, pawed at, banged around by a horse acting up. So we've reinforced that. In our case, we're using solid red oak because that's what we have available, and it's, pretty tough wood. We have the outside wall, we're just doing in 1-inch yellow poplar. So from the outside, it's gonna look more consistent, but there's not gonna be any actual pressure on that wall. That's just really for looks and to close it in. Rather than just screwing it to the wall, we're actually designing a system that uses tracks. Now, you could argue whether it's as durable in attachment because we have set it up differently, but the nice thing about this is it reduces the number of screws or nails being used, which means if something does fall apart, I have fewer sharp objects falling into a stall with a horse. So as you can see here, I've set up 2 2x2s with space in the middle. And then I attach 1 treated board at the bottom down here, so that supports the weight of the others. All the rest of the boards are free to slide up and down. The big advantage of this type of design is if a horse kicks it and let's say cracks, breaks, whatever, all I have to do, I could take off 1 of the tracks, replace the board, put it back. They're not all fastened separately. Once this is built up, we put a top plate on it like this, and that seals everything in. We'll keep working on this to kind of put the finishing touches, but that's the basic idea. When you use raw lumber, each board is not going to be exactly the same size. And sometimes it'll be wider on one end than the other. Some of it's going to be a little bit bowed. So it winds up making little gaps between the planks. Now that's okay for the purpose I'm using. However, as you can see, sometimes we wind up with a gap up here when it's all said and done. Now I could go to the effort of trimming things down and making it all match perfectly, but there's really no need for that. A month from now, if a horse kicks the board and snaps it and I have to replace something, well, it's not really going to benefit me to have it fitted to these sets of boards if another one's added. So what we're doing to hide this is simply adding a 2x2 board right here. We simply attach it to that top plate and it covers that gap. It gives me the flexibility I need to change out boards or whatever over the future. It also keeps, hopefully, wasp nest and such from getting up in there because I've got that kind of tightened down, and it hides that gap. So just sort of gives it the finishing touch. So I've got the first grill for the stall built and in place, and I actually like the way it turned out. Now, there's a lot of debate whether you should use wood balusters when dealing with horses, but in our case, we built this high enough up that the chance of this being kicked or snapped with a hoof is pretty slim. And after doing a bit of research, I found a couple of people who have done this, and years later, they haven't had to replace a single one. So we decided to go for it, because around here, wood is free and anything else is expensive. So what I did was I had Sean cut 2x2 just post, and I cut them to the size we wanted lengthwise. and I'm trying to get basically a nearly 8-foot stall height. So that's what it worked out to. I have a 2x6 plate on top and bottom that it fits in between. And then I have these 2x2 posts on each side. That holds the balusters in place. Now the time-consuming part of this is cutting and using these little spacers, just 2x2 blocks, and we set these spacers right in between each baluster to hold it in place. I've sized mine at roughly 3 inches, so a hoof cannot get caught in between them. That keeps it nice and safe. But most critically, we have lots and lots of light and airflow, which is really important to us. I also want to point out one modification we made to this end. We actually built a feed window. Now this dimension is only about 10 inches wide, but it's 18 inches high. And the reason we did that is the commercial grills tend to have shorter windows to feed grain. We want the ability to toss a couple of flakes of hay in. Your average hay bale is about 18 inches wide. So we shouldn't have any problem tossing 2 flakes of hay right through this window when we're in a rush. We don't want to walk in and out of each stall. So I'm pretty excited about this design. And then we'll just have a feed manger right in the base that it can fall right into. So a little bit time consuming, but not that difficult, or it didn't require a whole lot of skill. We'll see how it holds up.
So all my beautiful stacks of drying lumber are a complete mess now. We broke into these to start building that portion, and we're going to be using a lot more of this, which is good because the wood is getting off the racks and over there. But the other thing is, now that we have shelter, I want to be able to put this under cover and keep it dry, because I would have to cover it every time it rained. So some people ask, why did we start on stalls before we actually started on drying in a shelter for the RV? Well, turns out we had a few supplies and a few design issues that we had to deal with the barn, and we've got to keep moving here. We cannot just sit and wait. So we had materials for this, and we had the time to do it, so we went and tackled it right away. But we're not going to finish this. This just gives us a dry area to put things right now. It's only half done, or a little bit less than half done. But this also allowed us to hone up on our building skills. We haven't been building in a while. And get the saws out, get all the supplies we needed. We're ready to step over the barn now and start putting that up. So we're pretty excited.
Well, we're really excited at the progress that's happening here on this first half of our stall alley, or shed row, if you will. The second half, we have the holes dug, but we're going to have to postpone building that section until the barn is up. Meanwhile, if you've subscribed already, thank you very much. If not, be sure to do so you can stay in the loop here with everything going on at Redgate Farm. And feel free to leave a comment. We read every one of them.